The world of quantum mechanics is a complex world indeed. Wave functions, probabilities, illusion, reality, all of these concepts come together to produce one of the most fascinating fields of science today. But with such a complex field of study, there are bound to be many different interpretations. And today our panel of experts is diving face first into a debate about one of the possible interpretations, its benefits, its detriments, and why it might be absolutely bonkers. All this and more on this week's episode of Science Talks! That's right, folks. Welcome to another episode of Science Talks, the show where we somehow convince expert scientists to abandon their field of study for a few hours and come to talk about science with me, Gil Gly, the Science Man. This week on Science Talks, our topic of discussion is, in my opinion, one of the most fascinating interpretations of the world of quantum mechanics. I'm talking, of course, about the many worlds interpretation, folks. So what is the many worlds interpretation of quantum mechanics? Well, to help explain, let's look at one of the most famous thought experiments related to the field of study of quantum mechanics. Schrödinger's cat was a thought experiment hypothesized by the famous physicist Erwin Schrödinger. The experiment is set up as follows. A cat is placed into a box that has a small amount of radioactive material and an apparatus which detects radioactive decay. This apparatus is connected to a hammer, which, if the radioactive material decays, will break open a small vial of cyanide, thereby killing the cat. If the radioactive material does not decay, the cat remains alive. Easy, right? Of course not! This is science, you ding-dongs. Here's the catch. The entire experiment takes place in a closed container, so until the scientists check the box, the cat is both dead and alive. This may seem counterintuitive to some viewers. How can the cat be both dead and alive? The many worlds interpretation aims to provide an answer to this. The many worlds interpretation asserts that for every quantum choice that is made, for example, is the cat dead or alive, another universe exists where the opposite outcome is reality. So if the scientists went to open the box and find the cat alive, that means that there's another universe out there where the cat, unfortunately, is dead. But what do I know about quantum mechanics? I'm just a janitor with a degree from the University of Maryland University College, some expensive videography equipment, and way too much free time. But you know who does know a lot about quantum mechanics? Our panel of experts. So come on down.
We're already sitting here, Gil.
Alright, ladies and gentlemen, your panel of science people. First, we have Dr. Sidney Carver, a professor of science who's all about the many worlds interpretation. Next, we have Dr. Sidney Carver, a doctor of science who thinks the many worlds interpretation is faker than the Rolex I bought off an elderly Serbian man in Times Square, and posits that the wave-particle duality is the way to go. And finally, Dr. Sidney Carper, an orthopedic surgeon who's seen 2 episodes of Cosmos with Carl Sagan. Yeah, that's right. Piss off, Neil deGrasse Tyson. He thinks the many worlds interpretation is absolutely bonkers. Thank you all for being here, and may I say it's a strange coincidence you're all named Sydney.
Is this a bit or something?
Well, let's get things started. Our first question, it comes to us from Paul Fredrickson, a cow from northwest of Des Moines, Iowa. He asks, Gil, I'm a fan of your show, and I'm so happy you decided to use my question. I want to know, what are the advantages and disadvantages of the many worlds interpretation? Great question, Paul. Sydney, how about you take this one?
Thanks, Gil. Well, the thing about the many worlds interpretation is that it makes some of the more troubling aspects of quantum mechanics very simple.
For example, there's no longer the issue of the wave function collapse because it doesn't happen. Instead, new universes are formed, one for each possible result, to create an omniverse. The number of results can be found from the probabilities.
Instead of dealing with the abstract concept of the wave function, we're instead dealing with every possible outcome existing, but only one being labeled reality.
As the only one in this room who's a real doctor, I have to say both of you are so crazy. Look, Gil, my associate is crazy. There's no way to prove that this theory is correct. It's like something out of a bad science fiction movie. I think we all forgot about a little something called the law of conservation of mass. You can't find it on the corner of Basic Science Avenue, and how'd you get your PhD without knowing this? Road. Matter cannot be created or destroyed. Suggesting that every time a choice is made, an entire universe full of mass is being created somewhere parallel to our realm of consciousness is laughable. Not only that, but the many worlds interpretation leads to a deterministic universe. If If every possible outcome exists somewhere, it removes the concept of relativity.
An infinite omniverse? What's that about, huh? The many worlds interpretation rejects nearly all of the Copenhagen interpretation, which I strongly believe in. It rejects the idea that measurement affects the system. Instead, whenever a measurement is made in the many worlds interpretation, two realities form. Are we really expected to believe that every time a choice is made, another little universe crops up?
So it sounds to me like there's some debate about the validity of the many worlds interpretation, which is a brilliant segue into our next question from Richard Benedict III, an albino polar bear from the aquarium in Corpus Christi, Texas. He asks, what are the repercussions of a deterministic world as opposed to a probabilistic one?
That was a terrible segue.
Nobody asked you, Sydney. Sydney, do you have an answer for us?
Well, the biggest thing about the many worlds interpretation is that it calls into question the concept of free will. You see, everything can be boiled down to physics. Biology is just applied chemistry, chemistry is just applied physics. Therefore, our brain chemistry can be summed up as a quantum choice. Therefore, it makes sense to say that free will is an illusion because everything's already predetermined, so every choice you can possibly make results in a bunch of other wacky universes, which is a pretty cool thing to think about.
Get a load of this, doofus. An omniverse is not logical. Have you been overdosing on crazy pills
I
again?
have a prescription, okay?
Listen, Sydney, the wave particle duality theory makes much more sense when it comes to describing the world of quantum mechanics. Denying the collapse of the wave function doesn't follow any kind of logical measurement. Come on, let's listen to science for once, huh?
Say, Carver, what's the wave-particle duality? What's a wave function collapse?
Strap in, Gil. I'm about to blow your teeny tiny little mind. So get this. You know how you think an electron looks like a teeny tiny little marble? Get that trash right the hell out of here. It's a particle and a wave. It exists as both. Isn't that just absolute bonkers? As for the wave function collapse, this one's a bit more abstract. Every outcome exists as a probability until a measurement is made. This is called the wave function. When a measurement of one is made, the other ceases to exist, which is the collapse of the wave function.
The many worlds interpretation is preposterous, you big jabroni. This would mean that quantum mechanics is not valid. This means that a measurement is taken that is predetermined what is to come. Quantum mechanics is completely based on probability. This means that all of quantum mechanics is false? Are you trying to tell me that all of quantum mechanics is false? What next? Next you're going to tell me that the Earth orbits around the Sun.
The Earth does orbit around the Sun.
You shut your communist mouth, Sydney.
Looks like we have time for one final question. This one comes to us from Trevor Peterson, a 7-pound koi living in a pond in sunny Annapolis, Maryland. He asks, what makes you think you're right, huh? Great question. So scientists, what makes you think you're right, huh?
Well, the thing is that no matter how hard you try, you can't really disprove the many worlds interpretation. Because of our consciousness, it only exists in one version of our universe. It doesn't mean that others don't exist. In addition, the many worlds interpretation provides a complete and straightforward view of our universe, or rather omniverse, and clears up some of the more tricky aspects to swallow in the Copenhagen interpretation.
I mean, I guess you have a point, but I have science. It's the law of conservation of mass, not the highly suggested hypothesis of the conservation of mass. Mass cannot be created or destroyed. You can't just grow out your own universe by making a choice. That goes against all known laws of physics.
Have you ever considered that maybe we live in one of the universes where the laws of physics are different?
Have you ever considered getting a real degree from a real college?
I'm with Sydney on this one.
Thank you.
I guess this is why you pick scientists with different names.
Anyway, as I was saying, you can't prove the many worlds interpretation, but what you can prove is the Copenhagen interpretation via various probability experiments. I would love to explain them, but Gil didn't put that into my contract, so let's just put it this way. You know the probability experiments can be proven, and the many worlds interpretation cannot. And it's a load of baloney.
That's right, folks. The guest said baloney, which means it's time for the metric ton of baloney camp.
We have this room reserved.
Have you ever considered that maybe you live in one of the universes where you don't have this room reserved?
What are you talking about?
The many worlds interpretation, of course.
Just get out.